Hi everyone, today we will perform the assay of paracetamol tablet as per IP 2018. So aim of the exercise is to determine the percent content of paracetamol tablet as per IP 2018. Now introduction of assay of paracetamol tablets. So paracetamol tablet, also it is called acetaminophen in USP. Category is NSAID, that is the non-steroid anti-inflammatory drugs, and use of paracetamol tablet is analgesic, antipyretic, anti-inflammatory. And this is the structure of paracetamol, and IUPAC name of paracetamol is N,4-hydroxyphenylacetamide. These are the few brands available for paracetamol tablet. A well-known one, that is the Crocin, Calpol, and one more, that is the Dolo. Strength of tablet, we have the different strength of tablet, usually 500 milligram and 650 milligram dose is strength of tablet is used for adult. These are the requirements required for the performance of practical. So this is the spectrophotometer, double beam spectrophotometer. This is the electronic weighing balance. This is the cuvette required for the sample holding. Then mortar tester is required for the making powders, and these are other requirements or apparatus required for the preparations of solutions. This is the list of chemicals and reagents required for the assay of paracetamol. Distilled water, 0.1 mol sodium hydroxide or 1 mol of sodium hydroxide, paracetamol tablet. Now there is a preparations of 0.1 molar sodium hydroxide as per IP. 4 grams of sodium hydroxide dissolved and diluted to 1 liter with distilled water. It will give you 0.1 molar sodium hydroxide. Now, principle of paracetamol tablet. The assay of paracetamol tablet is based on UV spectrophotometry. Paracetamol is extracted with the help of 0.1 normal sodium hydroxide, diluted quantitatively to give absorbance in measurable range. Absorbance of solution is measured at 257 nanometer, and concentration of paracetamol can be calculated by using equation A equal to A 1% 1 centimeter into B into C. So this is the reactions we have for paracetamol and 0.1 normal sodium hydroxide. So it will give you the phenolate ion, and which will absorb the lambda max at around 257 nanometer. Now coming to the assay procedure. Weigh and powder 20 tablets. Weigh accurately a quantity of powder equivalent to 0.15 grams of paracetamol and transfer into 200 ml volumetric flask. Add 50 ml of 0.1 molar sodium hydroxide and shake for 5 minutes. Now add 100 ml distilled water and shake for another 15 minutes. Dilute with distilled water to produce 200 ml. Mix and filter. Discard first 10 ml filtrate and dilute 10 ml of filtrate with 100 ml with water. Now add 10 ml of resulting solution to 10 ml of 0.1 molar sodium hydroxide and dilute it to 100 ml with water. Mix well and measure the absorbance of resulting solution using 1 cm thick cell at 257 nanometer. Calculate the content of paracetamol taking 750 as the value of specific absorbance, or considered at a 1% 1 centimeter at the maximum at about 257 nanometer. Now IP limits for paracetamol tablet is given to you, that is 95 to 105%. So this is the summary, protocol summary is given to you. Label claim of tablet, suppose 500 milligram, and average weight of tablet that you can take 20 tablets and make the average weight of tablet, and suppose that is the 600 milligram. Now weight taken for analysis, that is 180 milligram as per the calculation for 150 milligram. Levodomain of paracetamol, that is 257 nanometer, which is given in the pharmacopoeia. Specific absorbance of paracetamol is also given in the pharmacopoeia. Now suppose absorbance of resultant final solution, that is maybe suppose 0.535. Now first we have calculation of equivalent weight. Label claim of tablet 500 milligram. So we can say that 600 milligram of tablet powder contain 500 milligram of drug, and X milligram of tablet powder contain 150 milligram of drug. So if you find out the X, you will get the 180 milligram of powder. So it is equivalent to 150 milligram of paracetamol drug. Now coming to the dilution scheme and factor calculation. So as per procedure, 180 milligram equivalent to 150 milligram of drug was dissolved in 200 ml volumetric flask. So final concentration of this solution is 750 microgram per ml. Now 10 ml was pipette out and diluted to 100 ml as per procedure, and let us suppose solution A. So if you find out the concentration of the solution A, it will be as 75 microgram per ml. Now again this solution A, pipette out 10 ml of sample from solution A and diluted to 100 ml is solution B. So concentration of solution B, that is 7.5 microgram per ml. In this both the dilutions we have 10 time dilutions. Right? You can also apply this equation to calculate the final concentrations of your diluted sample. That is concentration of initial concentration into initial volume equal to final concentration into final volume. Now coming to the dilution factor calculation. So dilution factor equal to final volume of solution A upon initial volume multiplied by final volume of solution B upon initial volume. Right. So final volume of solution A, that is 100 divided by initial volume 10 multiplied by 100 for solution B divided by 10. So simplified this will give you 100. So this solution is 100 times diluted. Now coming to the calculation part. So in the calculation from the equation A equal to A1 percentage 1 centimeter into B into C, where absorbance is, you can find out from the instrument, B is 1 centimeter and this specific absorbance is given in the pharmacopoeia. So just put the values of these all the A, B and A1 percentage 1 centimeter in the equation. You will get the concentration, that is 7.48 into 10 raised to minus 4 grams per 100 ml. Now if you convert these grams into milligrams, you will get 0.748 milligrams per 100 ml. Now you have prepared stock solution, that is 200 ml, and this is the drug content in 100 ml. So we have to convert into 200 ml. So we can say that 100 ml contain this much amount of drug. So what for 200? Simply multiply by 2. So it will give you 1.496 milligram per 200 ml. And again it is multiplied by dilution factor, which was calculated in the previous slide, that is 100. So you will get final answer, that is 149.6 milligram per 200 ml. Now next is 180 milligram of tablet powder was taken for the analysis. So we can say that 180 milligram of tablet powder contain this much of drug present. So what for average weight, that is 600 milligram. So 600 milligram tablet powder contain X milligram of paracetamol, and X equal to, if you find out, if you simplified this thing, you will get the answer 498.67 milligram per tablet of paracetamol. Right. And now we have equation percent content equal to estimated value upon label claim into 100. So this is, we have estimated value and label claim, that is 500 milligram. So you will get 99.73 percentage weight by weight content of the given paracetamol tablet. Now result, the percent content of given paracetamol tablet was found to be 99.73 percentage weight by weight. And conclusion is the given tablet of paracetamol thus complies with IP 2008. Thank you.